Hello, today's video lesson is on section 8.7, day 2. Let's get started. We left off on example 4. So we're solving the triangle using the law of cosines. So I've done a few notes here. Sorry for the scribble. It's early in the morning here and I'm just getting going. So this is the triangle we got. So we have A, B, C, sides 10, 3, and 8. Okay, so we need to find the smallest angle. And as you can see by the picture here, angle A is the smallest angle. So we're going to start out by using the law of cosines to determine that angle. So the cosine of A is equal to B squared plus C squared minus the A squared, all of that divided by 2BC. So that's probably the most difficult thing to get started is, first off, if you're using the law of cosines with your 3 sides, you got to find the smallest angle. And the problems that you'd have on a test or a quiz would be self-explanatory. Okay, so the cosine of A then, cosine of A would equal B squared, which is 8 squared. Okay, remember opposite of the angle is the side. So that's B, 3 is A, and C is 10. Opposite of the angle is the little letter C, and it's the side. A squared plus 10 squared minus 3 squared. All of that is divided by 2 times 8 times 10. When you calculate this out, the cosine of A is 0.9896, I should say. .96875. That'd be the cosine of A. So the cosine of A is 0.9687, and inverse cosine, you would have yourself the inverse cosine here, and the inverse cosine here. You're going to have yourself angle A to be 14.36. You can round to the 100th, okay? That'd be just fine. All right, so now we have A. So 14.36 is the little angle using the law of cosines. All right, now we're in the driver's seat by using the law of sines. The law of sines, we're going to find the smallest of the 2 angles that are left. Okay, so the smallest of the 2 angles would be angle B. So angle B is what we're trying to find. We know side B, and we know angle A and side A. So we're going to use the law of sines on our second step. So the sine of A over A is equal to sine of B over B. So that puts us at sine of 14.36 divided by 3, I should say, is equal to sine of B over 8. Sine of B over 8. Okay, to solve now for the sine of B, we're going to take 8 times the sine of 14.36. Is equal to 3 times the sine of B. 3 times the sine of B. Okay, now we're going to divide by 3 on both sides. And when we do that, we have the sine of B. That crosses that out. Sine of B is equal to 8 times the sine of 14.36. All of that is divided by 3. So the sine of B, when you calculate this all out, is about 0.66136 Okay, and that puts the angle B, if you take the inverse of each side, the sine, inverse sine of that side and this side. Okay, that puts us at 41 degrees is equal to B. Okay, so we have A, 14.36, B, 41.4, and by adding these two together, A and B, and subtracting from 180, you have 180 minus 55.76. And that puts the measure of angle C at 124.24. Okay, law of cosines, find that smallest angle first. Using this law of sines, find the second smallest angle, and then adding those two angles, subtract from 180, you get your last angle. And that's example 4. Most problems can be solved using more than one method. Choosing the most efficient method is sometimes not obvious. Okay, so number one, solving 30, 60, 90 or 45, 45, 90 formulas, use the 30, 60, 90 or 45, 45, 90 formulas. We learned that a few sections back. Or use the sine, cosine, or tangent ratios. Number two, solving any other right triangle, you can use sine, cosine, or tangent ratios. Number three, solving a triangle that is not a right triangle, you have to use the law of sines. If you know the measure of two angles in any side of a triangle, so angle, angle, side, or angle, side, angle. And you'd use the law of cosines if you know the measure of two sides and their included angle, side, angle, side, or you know the measures of the three sides of the triangle. So in summary, the law of sines, you would have angle, angle, side, angle, side, angle. The law of cosines, you would have side, angle, side, or side, side, side. We have two more examples today, example 5 and example 6. And on example 5 and 6, both, we need to determine whether we're going to use the law of sines or the law of cosines. And we should be used to solve the triangle, then solve the triangle. So we're going to first determine which one we're going to use first. So on this first one, I've got some of the notes already in. We have the angle A, okay? Angle A, which is 82 degrees. We have angle B, which is 44 degrees, and we have side B, which is 11. Okay, so in this case, we have an angle, and a side. Angle, angle, and a side. So if you're using this little helper here, angle, angle, side, we're going to start with the law of sines. Law of sines. So we'll first start with sine of B over B. So if we have this side B, we're going to have to get that ratio for sure. Okay, so sine of B over B first, and we're going to set that, we'll start with angle A, sine of A over A. Okay, so this is the law of sines, and the first one would be sine of 44 over B, which is 11, which is equal to sine of 82 over A. Sine of 82 over A. Now let's solve for, oops, got to put the A in there, not 82. Let's solve for A. Okay, so A times the sine of 44 is equal to 11 times the sine of 82. Okay, now I'm going to divide by the sine of 44. Divide by the sine of 44. Okay, so by solving then, you have side A to be 15.68. 15.68. So 100th to the hundredths. Okay, since we have A then, and we have these other two sides, 82 and 44, I'll move myself up there, 82 and 44, that's going to put the measure of angle C at 12.81 degrees. 81 degrees. And that's by taking 180, and we're going to subtract 126. And 126 is obtained by taking 44 and adding it to 82, 44 and 82. Okay, so that's 12.81, or I should say 54. I got a little ahead of myself here. Just hold on. 44, 82, 126. Okay, so the angle C is 54. Okay, so angle C is 54. We found A down here at 15.68. Put that in there. We have our B is given to us. Now we got to find, last step, we're going to find C. Okay, so we're going to use the law of sines again for C. And as you can see here, we got sine of B over B, sine of C over C. And we can see that we've got our two angles there. So let's go ahead with sine of B, which is sine of 44. Over the side B, which is 11. And that's equal to the sine of 54. We found 54 here, right here, 54. We've added that. That was on step 2 here. And we're going to divide that by side C. Solving for C then, cross multiply, divide, we end up with side C equal to 12.81. 12.81. So in this case, we started with the law, I should say angle, angle, side. Angle, angle, side, we use the law of sines. Law of sines. Example 5, letter B. We have an angle, 78.3. We have a side, B as 7. And we have a side, C as 11. Okay, so I've kind of drawn this in already. 78.3, angle B is not known, angle C is not known. We have side C as a 7 and side 11. So we have a side, an angle, and a side. A side, angle, and a side tells me that we're going to start with the law of cosine. Okay, so got it started here, law of cosine. And we're going to work with this angle A here because we know angle A. So we're going to use it to try to find the opposite side, A squared. So we're going to start with the A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of A. So let's plug in for A squared. We don't know. We're trying to find A squared. So our B squared is across from B, which is 7 squared. And our C is 11 squared. And we're going to take it times 2 times the B again, which is 7, times the C again, which is 11, times the cosine of A, cosine of 78.3. So that puts A squared to be 138.77. Taking the square root of both sides, you have A is 11.78. Okay, so you got your 11.78, and we've got one angle at 78.3. So now we can use the law of sines to find measure of angle B. So at measure of angle B is going to be found by taking sine of B and dividing it by a little b. Okay, so we're going to try to find this angle here. We're going to put it over the top of sine of A, because we know what A is, so sine of A, and we're going to divide by little a, which we just found. Okay, second step on step 2 would be sine of B over 7. Side B is 7, and that's going to equal sine of A, sine of 78.3. Over little a, which we found as 11.78. And as you cross multiply and divide, you end up with sine of B to be 0.58. 0.58. 188. 12. Inverse sine of both sides. Inverse of this side and inverse of this side. And you end up with angle B to be 35.58. So angle B, 35.58. And now we know two angles. So to find angle C, we're going to take the two angles we found and we're going to subtract from 180. So we're going to take 78.3, add it to 35.58, and subtract that number from 180, which is 180 minus the 113.88, and that's equal to 66.12. For a measure of angle C. Okay, last example of the day is example 6. Example 6. You can also use the law of cosines to solve some problems involving triangles. Okay, so here's an example of a triangular garden question. Triangular garden has dimensions of 54 and 48 feet and 62 feet. Find the angles at each corner of the garden. Okay, so here we go again. We're side, side, side. And if you have the side, 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 we're looking at the law of cosines. Now the tricky part is finding the smallest angle, okay? And the smallest angle in this triangle here is angle B. Okay, so we need to find that smallest angle first. So make sure you just kind of draw, when you draw out your triangles, my triangle here is the greatest, but you can see that angle B is the smallest. Okay, so that's what you're going to use. You're going to start with the law of cosines to find that. So the cosine of B, angle B, is going to be a squared plus c squared minus b squared all over 2ac. Okay, and as you plug the numbers in, you'd have cosine of B is equal to 62. Okay, so just make sure that when you draw your picture that you have the side, you know, your sides across from your angles. Okay, so side B, side A is 62, and side C is 54 in my picture there. Okay, so not 62 degrees, but 62, but it's squared. So it's 62 squared plus 54 squared. Then we're going to subtract 48 squared. All of it's going to be divided by 2 times the A, which is 62, and times the B, which is 54. So that makes the cosine of B equal to 4,456 divided by 66,696. And by taking the inverse of the cosine on both sides, that side and that side, you end up with angle B. Angle B is 48.28. So now we have 48.28 as our angle B. So once we got that off our plate, we're going to move right into the law of sines using this sine of B over B over here as our main ratio to work with. So we're going to take that sine of 48.28, sine of 48.28, and we're going to divide that by 48. And we're going to try to find the sine of C. Sine of C. Okay, so sine of C. So we found the smallest angle, then the next smallest angle. Okay, so let's make sure that you use that as your go-to. Okay, so 54. So smallest angle, then the next smallest. So if you cross multiply it and divide it here, you'd end up with the sine of C as sine of C as 0.8397. And that puts angle C by 57.11. So adding angle C and angle B together, 48.28 and 57.11, your last step is to find angle A by subtracting that sum from 180. So you'd end up with 180 minus 105.39. And that brings us to 74.61. 74.61 is the measure of angle A. And that's example 6, section 8.7 notes. Okay, that concludes the lesson for 8.7, Law of Cosines. I will save the PDF to the assignment today. And that's pretty much it for the videos this week. Just keep an eye on a quiz that will be posted on Thursday. Thank you.